Hi, we're Andrew Varkey and Elaine Sisson, Team 16 from WSU School of Electrical Engineering and Computer Science. Our capstone project explores source code authorship attribution under adversarial conditions, advised by PhD candidate Tashi Starwold. The reprogrammer has a kind of digital fingerprint, the way they name variables, structure functions, and format code. Machine learning models can analyze these patterns to identify who wrote a piece of code. But what happens if someone wants to hide their identity? Our project explores whether AI can be used to transform code in a way that causes these attribution models to make incorrect predictions.
So here's how our system works. We start with Python source code from 11 real GitHub developers. That code gets run through a feature extraction pipeline where we pull out token frequencies and stylometric features like naming conventions, indentation habits, and comment patterns. Those features feed into our 4 different machine learning classifiers: random forest, naive Bayes, SGD, and neural network. On clean, unmodified code, these models correctly identify the author 87 to 94% of the time. Then we flip to the attacker's side. We use larger language models, specifically Quen running locally through Ollama to rewrite our code. The large language model gets a transformation prompt telling it how to modify the code, and it produces a new version that works the same but looks stylistically different. We test that modified code against all 4 classifiers and measure whether they can still identify the author. What makes our approach unique is the evolutionary framework. We start with a seed prompt, generate candidate transformations, test them against all 4 classifiers, and keep the best one. That winner seeds the next generation. Over time, the prompts get smarter, evasion rates climb up, until they plateau. So through this process, we hit at the most 75% evasion rate on average. We also found that SGD was the most vulnerable classifier, while the neural network was the hardest to evade. Code authorship attribution is used in forensics, academic integrity, and supply chain security. Our research maps exactly which features are vulnerable and which models hold up, giving defenders concrete information to build more resilient systems. Our project shows that LLM-powered attacks are a real threat to code attribution, and evolutionary refinement is an effective way to expose those weaknesses. Thank you for watching,